All right, so today we're going to talk about this. I'm going to go over this 1.4 specifically on rules of exponents and try to help you out with some exponents. I'll just jump right into it. So, rules of exponents. If you are multiplying, so I guess first let me make sure you're clear on. So let's say we have like a to the m power, right? So this is called, a is called your base, and then m would be called your power. And that's probably all we're going to need to understand this. There's more to it, but I'm not sure if you need all that yet. So let's talk about this. So if you are multiplying the same base with exponents, all right, so here's what it's talking about. Let's say you have a to the m times a to the n, right? You have the same, you are multiplying the same base, and those base have exponents. What do? Well, in this case, you would say this becomes a to the m plus n. All right. So an example of this would be, let's say I have 5 squared times 5 to the third, right? If you think about this, it makes some good sense. 5 squared is just 5 times 5. And then we're saying times, right? Times. And then 5 to the third is just 5 times 5 times 5, right? So if you put that all together, then you get 5 to the fifth, right? And then 5 times 5 times 5 times 5 times 5 is indeed 5 to the fifth. All right. What about if you are dividing the same base? So you are dividing the same base with exponents. So what if you have a to the m divided by a to the n? That's what that's saying. Well, this one is going to equal a to the m subtract n. All right, so let's kind of look at that for a second. Let's say you have, I'm not going to do 5s this time. I'll do, x's, just so you don't think it's always got to be 5. So let's say you have x to the third divided by x to the second, right? Now we know x to the third is x times x times x, and x to the second is x times x. And I hope you know that anything, whatever the number is, if it's 5 divided by 5, that's going to equal 1. If it's 100 divided by 100, it's going to equal 1. If it's x divided by x, it's going to equal 1, right? Because how many times does x go into itself? 1 time, right? Or you can think of it as canceling out, and you make sure you put a 1 there. Or you can think of it as, reducing, however you like to think about it, but regardless, it's going to equal 1. So what does that mean? Well, that means if I think about this, x divided by x, these two can kind of reduce to 1. These two can also reduce to 1, right? You're kind of looking at this group right here and then that group right there, and they're kind of, I like to think about them as canceling each other out, but that's just, jargon talk, I guess you can say. Regardless, they're reducing to 1. So this reduces to 1, that reduces to 1, and then you just have what's left over. 1 times x in the numerator, which is just x, and then 1 times 1 in the denominator, which is just 1, which overall is just x. So x to what power? X to the first power, right? Because 3 minus 2 is 1. Hopefully that makes sense to you. All right. 0 is the exponent. So a to the 0 power is 1. All right, this is a property that you just need to, there's good reason for it, but it's harder to explain than all the rest of them. So I'm just going to tell you that instead of trying to complicate things with all these deep explanations on it, just take my word that anything, if you have it to the 0 power, it is 1. Anything to the 0 power is 1. You are raising an exponent to a power. So you have a base, and that base has an exponent, and you're raising that exponent to a power. So you have a, let's just say, to the m, and then that to the n, right? This is what it's talking about. That's going to equal a to the m times n. So I'll show you what I'm talking about, and I'll work out an example. So I'll do it with numbers this time. Let's say 2 to the 3rd power to the 2nd power. All right. Well, I'm going to come under here. So 2 to the 3rd power to the 2nd power. 2 to the 3rd power. Or let me change it from 2 just so I don't want to confuse anybody. Let me say, I'll say 4. 4 to the 3rd power to the 2nd power, right? So that's going to equal, first, I'm saying 4 to the 3rd. What does that really mean? That really means 4 times 4 times 4, right? And then that is to the 2nd power. Well, what does that really mean? Well, that really means 4 times 4 times 4 once, multiplied by the same thing again. 4 times 4 times 4. And then if I remove the parentheses and I say 4 times 4 times 4 times 4 times 4 times 4, then I get 4 to the 6th. And that's because 3 times 2 is 6. So that becomes 4 to the 6th. And you could put that in your calculator and get the real answer, but I'm not going to bother with that. All right. What about when the exponent is negative? So what about if we have, I'm going to say a to the negative m. What is that equal to? Well, that becomes 1 over a to the positive m. And this is also kind of a property that we could get into, like how it all works, but I don't know that would be beneficial to you. So I'm going to give you an example and say if you have, 5 to the negative 3, if you put that in your calculator, it's not, well, I'll just say negative 2 because most people are familiar with 5 squared, right? 5, if I ask you what's 5 squared, you're going to say 25. And if I say what's 5 to the negative 2 power, some people will say, oh, negative 25. But no, that is not correct. You put it in your calculator and you'll see that it's 0.04, right? And how is that? Well, because it becomes 1 over 5 squared, which is 1 over 25, right? Which is what your calculator tells you, 0.04. So let me kind of give you a little bit more on this. So let's say we have this situation and it's like 5 to the negative square, or let me say 5 to the negative square times x, squared all over, 2 y to the negative 3rd, right? How do you simplify this? Well, first, anytime you're dealing with negatives, and I probably should have showed that in an example, you should remember that every number can be written over 1. Every number is a fraction. All right, so in this case, we see a fraction bar, so it kind of helps us. But only the exponents that are negative are going to be moving. So sometimes people say, oh, you just flip it, right? Well, it's not. I understand why people say that. It looks like you just flip it, right? If you come back up here, it looks like this is just being flipped. But that's not the case. Not necessarily. In this, the answer would be x squared y cubed over 2 times 5 squared. Like that. Now that wasn't just flipping it, right? We didn't just flip everything. But the ones that had negative exponents, we pushed them to the denominator and made their exponent positive, right? Now 2 has an exponent of 1. If you don't see an exponent, it has an exponent of 1. But then this y to the negative 3, that was in the denominator and it was negative, so you push it to the numerator. So if it's in the numerator and it's negative, you push it to the denominator and make the exponent positive. If it's in the denominator and the exponent is negative, then you push the whole term to the numerator and you make the exponent positive. So I'll give you one more. So if I have 5a squared b to the negative 3 c to the 4th over 2x to the negative squared y to the 3rd z, right? I'm only going for the terms that have negative exponents, right? So that's this one and that's this one. And the one in the numerator has to be moved to the denominator, and the one in the denominator has to be moved to the numerator. So I'm going to say 5a squared c to the 4th. They're still in the numerator, but now this x to the negative 2 comes to the numerator, and its exponent becomes positive. All right, and for the denominator, I have 2, and then there was a y cubed and a z, right? But this b right here got moved to the denominator, and its exponent became positive. All right, so hopefully that makes sense to you. That's the exponent rules that you're going to need to know. Let's see if I have some examples I can work out with these rules. All right, there's kind of the same rules again. Let's look at this. So, simplify. Your answer should contain only positive exponents. Yes, in math, is considered not fully simplified if you have negative exponents in your answer. All right, so let's check it. All right. 3y x to the negative 1 times 4x to the negative 2y squared. So first thing, when I'm dealing with exponents that are negative, basically at the end, you have to make sure they're positive. So you can get them positive to begin with, or you can leave them positive, or you can get them positive at the end. I prefer to just go ahead and get them positive. So this becomes, I'm thinking about this like a fraction, right? And that like a fraction. And now this is coming down. So it becomes 3y over x times, and then I got 4y squared over x squared. And now I'm multiplying, right? I'm multiplying. Now, what sometimes people do is they forget when they're multiplying regular numbers how to do that. 3 times 4 is still 12. And when you multiply fractions, you multiply the numerators together and the denominators together, straight across. So I'm just saying 3 times 4, which is 12. And then I'm saying y times y squared, which is y cubed, divided by x to the first times x squared is x cubed. And I'm finished. That's as simple as it can get. What about this one? Same thing from me here, right? I'm going to go ahead and get the x's, or the negative exponents positive. That's how I prefer to do it. So this becomes, I'm looking at each individual piece of it. I mean, you can write it like this if you want. think about terms, I mean, basically, there's a lot of freedom in going over this. So I know that this is coming to the denominator. I know that's coming to the denominator. So this is going to be 4 over x to the 4th, and then y, right? Anything to the 0 power is just 1. So I'm just going to say times 1 times 2 over y to the 3rd. All right, so anything times 1 is still 1, or is itself, excuse me. So I don't really need this 1 when I'm multiplying. I mean, I don't want you to think it's magic. Maybe you want to make it a fraction so it matches or something. I don't know. 1 over 1 is still 1. All right, so then 4 times 1 times 2 is 8. And then x to the 4th times 1 times y to the 3rd is just x to the 4th, y to the 3rd. And this would be your answer. Okay, let's do, what about this one? No negative exponents. I do have an exponent of 0, which means that number is going to be, or that term, the one with 0, right? Some people say, oh, since there's a x to a, since a 0 is in the exponent, that means it's just equal to 1. No, that means whatever's to the x to the 0 power is equal to 1. So this thing right here, this becomes 4, y to the 4th times 2, and then that x to the 0 power is just 1, so times 1, and then times y to the 4th. And when we're doing this, we can multiply. Since we're multiplying everything together, I multiply my numbers. 4 times 2 times 1, which is 8. Then I multiply my variables. Y to the 4th times y to the 4th. We're adding them, and that becomes y to the 8th. All right. So I got 4v to the 4th times 4u to the 4th times v to the 4th. So I'm going to go ahead and deal with that negative exponent and say, since everything's being multiplied, I could think about it like one big term. And then this comes down to the denominator. So it becomes 4v to the 4th times 4v to the 4th all over u to the 4th, right? Now 4 times 4 is 16. You're not adding these two numbers, you're multiplying them. But then v to the 4th times v to the 4th is v to the 8th over u to the 4th. Okay. All right. Yeah, let's do some more. So 3y to the 3rd times 4x to the 0, y squared. So x to the 0, right? That just becomes 1. So we got 3 times 4 is 12. And then y cubed times y squared is y to the 5th. If you feel like you're getting the hang of this, feel free to, pause the video, try to do it yourself. And then once you try to do it, maybe you're right, maybe you're wrong, but regardless, you're going to learn something. And, press play after that and then see how it's done. All right, so here I'm going to go ahead and say this is, both of these have negative exponents right now. So I'm going to say 1 over x cubed y to the 4th. Or, it might be easier for you since it's already to that power. That becomes x to the negative 3 times 4 power. X to the negative 3 times 4th power times y to the negative 4 times 4 power, because remember, when you have a base, right, a base with a power to another power, you multiply those powers. So we have a base with a power to another power. This is going to both of them, right? So hopefully that makes sense to you. And then times negative y. All right, let's continue with this. This becomes x to the negative 12th. We are multiplying these, so this is x to the negative 12th times y to the negative 16th times, now this is negative y to the first. All right, so this is times, you can think of it like negative 1 times y to the first, right? All right, take it a little further. We can combine the y's if you want. Negative, remember when you're multiplying y's together, which we are, right? We're multiplying all this together. You just add the exponent. Negative 16 plus 1 is negative 15. So this is, and then this whole thing's being multiplied by negative 1. So I'm going to say negative 1 times x to the negative 12 times y to the negative 15, right? We're almost to the answer. And your final answer would be, we got to get those negatives in the denominator, right? The negative powers, we can't have them negative powers. We got to move the whole term to the denominator. So it's going to be negative 1 over x to the positive 12th times y to the positive 15th. And this would be your final answer. All right. We see all these things being multiplied together with, and then an exponent on the outside. Well, if you remember the order of operations, right? Parentheses is first, then exponents, then, multiplication or division from left to right, and then addition or subtraction from left to right. So let's think about what's in parentheses. Can we combine them? Well, this is all being multiplied together inside the parentheses. This is an x to the first power times the x to the fifth power. So first we got a negative and a negative being multiplied together, which is going to make this positive. Then I got x to the fifth times x. That becomes x to the sixth. And then y to the 0 power. Anything to the 0 power is just 1, so that just becomes times 1. X to the 6th times 1 is still x to the 6th. And then it becomes to the third. X to the 6th to the third becomes x to the 6th times 3, which is x to the 18th. All right, so let's do this again. First, we look in the parentheses. Can I simplify it? I mean, I could move that negative down to the denominator and make it positive, but it's not 100% necessary. You can do that, but you just have to make sure that's done at the end. Sometimes I'll do it in the beginning, but other times, there's a strategy that makes it a little bit simpler to not do it at the beginning. And since this one has a power, I might as well go ahead and distribute this power, right? So since it's being this to this power, everything gets that power. So that's negative 2 to the negative 1 power times m to the negative 5th, right? And since it's a base with a power to another power, they multiply. So times negative 1 times n to the third times negative 1, right? And then times m to the fourth times n to the negative second. Simplify this some, so I can think about what's going to be in the denominator. I guess I'll just write one step at a time. So this becomes negative 2 to the negative 1. I'll leave it like that. And then this becomes m. Now, a negative 5 times a negative 1 becomes a positive 5. Times n, negative, or a 3 times a negative 1 becomes negative 3. Times m to the 4th times n to the negative 2. I can combine m to the 5th and m to the 4th, and then n to the negative 3rd and n to the negative 2nd. So I'm going to continue to write this out and say this is negative 2 to the negative 1 times m to the 5th times n to the 4th is m to the 9th, right? You're adding them. And then n to the negative 3rd times n to the negative 2nd is n to the negative 5th. All right, we would be at our final answer, but we can't have our answer with negative exponents. So now I would say create yourself like a fraction bar. Remember, everything has a fraction bar, even if you don't see it. And I know that this needs to get pushed to the denominator and this, right? The negative's not. This negative stays in the numerator, but that goes down. So this becomes negative, and then I got m to the 9th over 2 to the positive first now. And 2 to the positive first is just 2. You can just say 2. And then n to the 5th. So this would be your final answer. You don't necessarily have to write it like that. You could say negative m to the 9th over 2n to the 5th, like that. Either way, it's the same thing. All right, we're almost done here, so this might as well just keep going. 2m to the negative 3rd times n to the 5th times 2m to the 5th to the negative 2nd. So if I have a negative out here, I would go ahead and just distribute that. So this is 2 to the m to the negative 3rd n to the 5th times, now 2 to the negative 2 times m to the negative 10th, right? So that's be my first step. Now I'm going to combine, right? This is a 2 to the 1st, and that's a 2 to the negative 2nd. Well, the same thing. They're a common base with exponents. So I can say that's 2 to the 1 plus negative 2 becomes negative 1, right? And then I got times m to the negative 13th times n to the 5th. And now, since I'm basically as simple as I'm going to be, I'm going to think about it as a numerator-denominator situation, and the ones that need to move down, this one and that one will. So that becomes n to the 5th all over 2 m to the 13th. And that's my answer. All right, almost finished. About to go ahead. Now, everything in here is x squared times y to the 4th times negative 2 y x to the 0. Now, I'm going to go ahead and distribute this, right? Distribute that. Well, actually, inside the parentheses, I know that x to the 0 is just 1. So that's just 1. So 2 times 1 is just 2. So it's like nothing. It's like this is just, since we're multiplying and it's 1, then you don't really need it. All right. So I'm going to rewrite this. That's what I'll do. I don't want you to think I'm scribbling it out and doing magic, right? So this is x squared y to the 4th. Now times negative 2. I can bring the negative, wherever I want, but I'll just say times. I like to think of negatives when you're multiplying as negative 1 times 2 times y, and then times 1. And that's to the negative third. All right, so I need to distribute. Everything's being multiplied. I need to distribute that negative 3 in there. So this is x to the negative 6 times y to the negative 12th times negative 1 to the negative third times 2 to the negative third times y to the negative third, and then, you could say times 1 to the negative third if you wanted, but 1 to any power is still 1. That's another exponent property. All right, I'm going to combine stuff, try to simplify it. Yeah, so this is x to the negative 6th times y to the negative 15th times negative 1 to the negative third times 2 to the negative third, and all right, now we as simple as we can get it without handling the negative. So I'm going to think of this like a fraction bar. Everything up here is numerator, down here is denominator, right? Well, all of these have negative powers. So that goes to the denominator, that goes to the denominator, that goes to the denominator, that goes to the denominator. So then in the numerator, what do I have? It's not just, you don't have nothing, you have a 1, because this always just a 1 time. You can say anything is times 1. So you have a 1 in the numerator, and then in the denominator you have x to the positive 6, y to the positive 15th. Now this becomes negative 1 to the positive third times, 2 to the positive third. All right, we can simplify this a little further still. 2 to the third is 8. Negative 1 to the third is negative 1. So this becomes 1 over negative 8, x to the 6th, y to the 15th, and that's your final answer. So these are kind of weird ones, but we worked through them. All right, yep. Hopefully you found that helpful.